So here what we have is two triangles. Everyone see the first triangle and the second triangle. And I want somebody to tell me before we even get into these triangles in particular, what similar triangles are. So does anyone remember what similar triangles are? So they have to have this and they have to have that. Okay. Michael?
They're not like, they're the same like angles and stuff, they're just smaller, like one's big portion.
Okay, so you're getting an idea. I think you understand it. Someone else want to put it maybe differently? Caroline?
A triangle that it has the same shape but not necessarily the same size.
Okay, and those key words are there. Do similar triangles have the same shape? Yes, that means they have the same angles, by the way. That's why they have the same shape, because they have the same angles. But then, do they necessarily have the same size? No. So, can two triangles be similar if they're the same size?
Yes.
Yes. And what would those be called if they're the same size and same shape? They're technically congruent, but you can still say that they're similar. So, remember the symbol for similar? That's your symbol for similar. And the symbol for congruent is saying not only is it similar, it's more than similar. Does that kind of make sense? Similar by itself means same angles. But congruent means same angles and equal sides in that case. Okay, I'm going to keep the symbol up here. And I want somebody to tell me if these two triangles are similar, but you have to prove why. So you can't just say, yeah, they're similar. No, they're similar. They're not similar, but I need a reason why or why not. So are these similar is what I'm asking. They're not necessarily the same size, so that's out of the box, but do they have the same shape? Sophie?
Well, I think they are similar.
Okay, why?
Because, well, they have opposite angles, and they're the same shape.
Okay, what do you mean by opposite angles?
Well, A and D, they're congruent.
Okay, these two angles are congruent?
Yes,
Good.
and E and B are congruent.
E and B are congruent?
Because they both have,
they're both right angles. Very nice. But are these two angles the same?
Yes.
Does anyone know why these two angles are the same? There's actually two reasons. One we've talked about. The other one is a technical thing in geometry. So, Braden, these two right here, this angle and this angle, are they the same?
Yeah.
Why?
Because
They are the term blank angles. Starts with a V. Josie? Vertical angles. So what I can do here, I can say those two are the same. Yeah?
Well, also because A and B are the same and D and E are the same, it has to equal 180. So since they're both the same, the other triangles have to be the same because they both have to equal 180.
Good thinking. Okay, geometric, is that kind of what you're saying, or do you have a question?
Is it because they also have corresponding sides?
Okay, yes, they do have corresponding sides and corresponding angles. So this is what Michael said. Do these two triangles have this set of equal angles? Mm-hmm. And this set of equal angles? So 2 out of the 3 are the exact same. So automatically the third angles have to be the same as well, right? So this were 90 and that's 30. 90 and 30. Wouldn't these have to be the same no matter what? So there are two reasons. Vertical angles, and if 2 out of the 3 are equal, all of them are equal. And that's actually geometry there. Yep.
do all triangles equal 180?
All the angles added together have to be 180 if it's a real triangle. If it's not a real triangle, then you're going to have less or more than that, 180. Good. Yep. That's good review, guys. Good. If these guys all share the same angles, we realize they don't have the same side lengths. They're not exactly the same size. So can somebody give me a similarity statement? I want a similarity statement. Triangle blah, blah, blah is similar to triangle blah, blah, blah. Give it to me. Somebody. Because this is going to help us out on the actual problem itself. Okay, I'm going to have Jensen give me the first part. Go ahead, whichever one you want.
A, B, C.
Okay, that's all you give me. Triangle A, B, C. Now listen to me very carefully. If you gave me triangle ABC, there's only one way I can give you the next triangle. There's only one way. Not 2 ways, not 3. All right, I need the next part. Emma Grace. Okay, I'm gonna write it down and I'm gonna test it. DEC. All right, are angles A and D the same?
Yes.
E and B?
Yes.
C and C?
Yes.
So this is a similarity statement. That is correct. That's good. You got it, guys. Could you have written this differently, though? Could you have written it BCA? Yeah, if I put ECD. So do you see there's variety? We picked this one. We're good with it. Okay, good. They're similar. If they're similar, they have the same angles, but not the same sides, right? But what do we know about their sides? They're not the same, but they are, and here's the key word, fill it in, John.
Proportional.
They're proportional. Okay, so this is what I'm going to do here. I'm going to come up with the proportional sides. Okay, side, let's go with, let's just start with AB, okay? So segment AB. Does anyone know which side is proportional to AB? And there's only one answer here. You cannot give it to me in many ways. AB. Bella.
ED.
Close.
Segment ED.
Close. It's not ED.
DE.
DE.
D.
Now, can somebody tell me why I was so picky with Bella? And she kept saying ED. And I'm like, man, she's so close, but it's not ED, it's DE. Can anyone tell me why it's DE and not ED? Why am I so picky? Callie, go ahead. You can say the same or congruent.
Congruent.
Okay.
And then,
So you want to match that up. Match it up. You don't want to confuse yourself by switching things around. Okay. Can anyone tell me what side is, I'm going to say it here, corresponding to BC? Can anyone tell me what corresponds to BC, side or segment BC? Elizabeth?
EC.
Let's see, BC and EC. Is she correct?
Yes.
Yes, because B and E are the same and C are obviously the same. All right, great. You guys notice anything about these? I have one over another, another over the other. I don't know how to say it. Proportional.
They all be one because.
Oh, yeah, here's a good question. Like, what do you do with that? Well, does anyone know what the actual measurement of AB is?
10.
It's 10. So I'm just going to rewrite it down here so you can see the matching part. Anyone know what BC is? 7.5. Does anyone know what DE is?
X.
Yeah, it's X. I don't know. That's what we're trying to find, by the way. And EC.
12.
Do you guys see my proportion here? But I'm going to do something else. I'm going to work it out this way, and then I'll work it out two other ways. You can do it two other ways. Yeah, and I hope you'll be able to see the relationship. Okay, John, do you have a question?
Yeah. So, like, I know that it would work if you did AB and or you just switched them around. But would it work if you did AB and EC, AB over EC? Because then you're crossing different products. So you're not crossing AB and EC, but you're crossing EC and B.
So basically, maybe could you switch these two
Yeah.
around? Good question. I'm going to answer that when I redo it. But here's what I want all of you to do. Everyone, please look up at the board. And I'm going to say it a different way, and you're going to repeat it in that different way. So just listen this first time. Segment AB is to segment BC as segment DE is to segment EC. And you know what? Just to help us with all those words, I'm just going to call it AB is to BC as DE is to EC. Can we do that? Okay, go ahead. AB is to as DE is to EC. Okay, ready? So I'm going to point it out here from that proportion. AB is to BC as DE is to EC. So this relates to this as this relates to that. You're like, what? These two side measurements, and guys, it's actually, you know what it is? We're talking trigonometry right here. So 8th graders, right now, I'm going through trig. right now, little piece at a time. Remember, did I talk to you about bite size?
Yeah.
This is your bite size. This side relates to this side on this first little triangle, as this side relates to this side on the bigger triangle. There's a relationship, and it's proportional. And we'll look at that more when I flip it around. Yes, sir?
How would you know, like, which ones to put on the bottom or the top? Like, could you put BC is to AB, or, like, could you, like, switch the BC and the AB and the BC and the B?
That's a good question, right? Because I just kind of picked letters, and then these match up. But is there any other way to work it out? Let's hold that question. It's kind of John and Max's question, and maybe some of you are thinking, wait, let's work it out, and then let's see if that we can do something with that. Okay, cross multiply. What's 10 times 120? 120. What's 7.5 times x?
You said 10 times 120.
Oh, yeah, sorry. Sometimes I get my answer too early. So 10 times 12 is, 120, and 7.5 times x is 7.5x. And then how do I solve that? Divide both sides by 7.5. Yeah, because I want to get x by itself. So this is my problem, isn't it? So I got to move it here, got to move it there. So 75 goes into 120 once, and that would be 25, 45. So I'll do it just so we're not. So 5, 11, yeah, 45 bring down 0. 75 goes into 450. Okay, I'm going to try 75 times 6, 30, 42, 45. Good. All right, 6 times. Evenly. So what is the length of segment DE or ED? What is it? 16. It's 16 right there. So this x equals 16 is my answer. Okay, and you could have divided that out. Yes, sir?
I did it a different way. I did 10 over x times 7.5 times over 12.
Did you get the same thing?
Yes, I did.
Ooh, so it worked.
Okay, you guys are doing something, and you're asking good questions. You're going to get an answer that's going to help you out in 2 years even more. Because when I look at this right here, you can manipulate to make it easier to work out if you know what proportions really are. So what I'm going to do here is going kind of what Jensen said, is I'm going to erase this work. We already know it's 16. And I'll erase this. And Max, your question was, can you like flip them around? Yeah. BC is to AB as EC is to DE. Okay, so what I'm going to do is I'm going to point those things out. BC relates to AB as EC relates to ED. Is that true? Yeah. Like, are these two related? Yeah, so 7.5 is to 10 as 12 is to x, right?
But isn't that still the same cross product?
It's same cross product. So did I have to start with AB? No. Okay, ready, guys? Jensen, I don't know if you did this exactly, but let's see what happens. Ready? See if you guys can follow me on this one. AB is to DE as BC is to EC. Do you guys know what I did with these four?
You just switched them.
What I do? Yeah, I switched it a little bit. Let's see. AB is to DE. Is that true? Do these two relate somehow?
Mm-hmm.
As BC relates to EC. Are these two related somehow?
Yes.
Let's put the numbers in because I don't think that's true. I'm kind of skeptical. What's AB? 10. What's DE? Uh-oh. What's BC? And what is
12.
EC?
Still the same one.
Same problem. You're going to do 10 times 12, 120. 7.5 times x, 7.5x, divide by 7.5, you get your 16.
So, do you think there'd be an easy way besides doing the 10 times the 7.5 first? Do you think that would be easier?
No, I would say this is the only way on this problem, but 2 years from now, if you manipulate it, you make your life easier. Because sometimes they're going to give you all these numbers. They're going to give you like something like x plus 2. So you can make it easier if you rotate it around, but it's still proportional. So is there only one way to do this problem? No. But you got to understand AB is to DE as BC is to EC. Okay? Now I'm going to do one more thing in just a moment and see if I'm right or wrong. Yes, ma'am.
Could you do BA is to CD as EB is to CB?
So just basically switch all the letters? Is that so BA, CB, and then what else?
Or you're switching like the order
Mm-hmm,
of them.
mm-hmm, mm-hmm.
Then you can switch the letters.
Technically, you could say BA, CB, ED, CE. Hmm? Let me do this to you guys and tell me if it's right or wrong. Oh, that's not right. I forgot what I had there. AB is to DE as EC.
BC was first.
Okay, BC. So I'm going to go EC is to CB. Or BC, I guess. Just to make it consistent. All right. Is that good? All right. AB is to DE. Is that so good? Is that good? This is to that. As EC is to CB. So this is what I did. Small triangle to big triangle. That's good. Big triangle to small triangle. Does this relate to x in the exact same way as 12 relates to 7.5?
Yeah.
No. Ready? Let's put some numbers because some of you are. All right, what's AB? Okay, what's DE? X. All right, so that's good. What's EC? And what's... Is that going to give me the same answer as all the other ones I've done? No, what's going to happen? You're going to get 10 times 7.5, which is 75, equals 12x. I divide both sides by 12, and I get some decimal number that is not correct. So listen to me carefully. When I said read it AB is to DE as EC is to BC, that's actually not true. AB is to DE, so far so good, but I would have to switch these around to make it true. Because I'm talking about small triangle to big triangle as small triangle is to big triangle. That's correct. But if I go small to big, then big to small, it's not the same thing. Or I could do it like this. This side is to this side, right? Longer side is to smaller side, as longer side is to smaller side. I can do that. Or I can do smaller side, bigger side, smaller side, bigger side. Do you guys kind of get that at all? Because I'm going to test you out. It's hard to, so I asked the question, did you guys get it? And I saw some of you looking down. I don't get it. I don't get it either if I'm looking down. So look at the board so you can kind of see what's going on. Maybe you can pick it up by visualizing it. So let me give you one and see if you guys are understanding it. Page 582. Do number 8. It says write a proportion to find the missing measure x. So you're just doing number 8. Yes, ma'am.
When you say like a number is 2, that number, like, do you mean like moves across from the fraction or like that one fraction?
That one fraction. The numerator is to the denominator as the numerator is to the denominator. But if I rotate it around, technically I could say something else. But that's what I mean when I'm reading it, is to this, is to that. That's why I had to take a whole nother day on this, because it's one thing to get the problem right if we just do it always one way, but it's another thing to understand what you're actually doing. But that's harder to teach. Oh my. and they wanted a proportion, and so do I. I don't want the answer by itself. That's fine. I want a proportion. All right, they give me these two triangles. There's a third angle that's also equal. What are the angles that are also equal that are not shown up here necessarily? Timothy? Yeah, this angle is equal to that angle for two reasons. Vertical angles, and if two angles are the same, the third one has to be the same in triangles. Have an answer? Okay, hold the answer. Do you have an answer?
I have like,
Go ahead.
Can we simplify our proportion?
You can simplify it before you multiply it.
No, like the in proportion.
It should. The answer I see is one number simple.
So you want x equals
Something, yeah. Yeah, that's what I mean. Yeah, x equals blah. Just that number equals whatever. Okay. There's going to be a variety, but we're all going to have a similar proportionality. Doesn't mean you have to have that same exact. I want to see if you guys got this. This would be really cool. Okay, give me your proportion just with the numbers. Give me the numbers. Like this number is to this number as this number is to that number, and one of them will be x. Okay, Marissa, give me one.
8 is to 10 as 4 is to x.
Okay, I'm going to go 8 is to 10 as 4 is to x. And I'm going to test it first. Okay, this side right here, the one between the 1 and the 2 tick marks, is to the one, okay, sorry, as to 10, as this one. So this side is to that side. I'm okay with that. So what's the other one? 4, that's good, is to x. That is also good. It works. That is correct. I'm not going to solve it yet. Did anyone get a different proportion? Okay, go ahead.
I don't understand how you get the
Proportion?
yeah.
So all we're doing is we're picking, you could pick two sides on the one triangle, and then the same two sides or the corresponding sides on the other triangle, or you have a variety here. So maybe if you see some, you'll be able to pick it up. All right, Emma Grace?
Could you do x is
Okay, sorry. Go ahead.
x is to 10 and 4 is to 8?
Okay, look at the original one, which I accepted. Can you do x is to 10 as 4 is to 8? You see how this, if I just rotated it, kind of rotated and like flipped it around, it would be that one. So that's good. Anyone else? Different one, Max?
Why would you not? How do you know if you use a 6 or not?
You could. Did anyone use a 6? So some people did use 6. Let's see what you got. Michael, you use a 6? Go ahead.
I said 8 is to 4 as 6 is to x.
8 is to 4 as 6 is to x. All right, let me check this out. This side is to this side. They're corresponding as 6 is to x. So are these two sides corresponding? If you would have used 6, you would have had to use this side right here. You see what I'm saying? I don't know, and we don't need to know that one, so we don't use it necessarily. Although, I mean, you could find out. That's okay. That's good thinking. But do you see why we wouldn't use that one? Because it points us to that one. So, Max, does that answer your question? If I use this, I'd have to use that, and that doesn't help me.
Wait, so why did you 4 is to
Oh, go ahead.
4 is to x as 8 is to 6?
4 is to, as 8 is to 6. Okay, ready? 4 is to x. These relate. As 8 is to 6. Okay, 4s. You guys see how these are corresponding? Are these corresponding? These are, and those are. So we can't use that one. Anyone want to give me something else? I'm testing these out. Elizabeth,
I have a question.
go ahead.
How do you know what order to write everything? Because I did the one
Can you
with
do it?
6.
Oh, okay.
And how do you know how
Yeah.
the pairs are?
Basically, I'll say this. If you pick whatever side you pick on one triangle, 10, you're going to have to use in that proportion its corresponding side, x. So you got to use those. You can relate them by x over 10 or 10 over x. Here's another way you could have written this. Did anyone write it that way? Just flip them. Okay, 1. So both of these are good. And you see the order, does it really matter as far as here? As long as you're relating corresponding parts. Okay, did anyone do anything else? Because there is one more way you could have done it. Really, one more way. Basically, 4 total ways you could have done it. Jack?
I wrote this like letters.
Okay, so you did the letters. Did you get the numbers in there?
No.
You want to try to get the numbers? Because that'll verify it with us.
It's like the bottom one.
This one?
I think so.
Check it just to make sure. Jensen?
Not had D6 because there's not like an actual part.
Yeah, and if I were trying to find, like, let's say this was Y, you could use 6.
Okay, so we couldn't have used 6 as a problem.
Yeah, you could have used a proportion, but you would have ended up with something you didn't know. So you'd have either X and Y, and then you can't solve it, or you would just have something you're just blank. Yep.
When you solve it, wouldn't...
Oh, yeah, good. Which one do you want to solve? 1, 2, or 3? Your choice.
Trying to answer the question.
Go ahead.
When you get your answer, isn't X the same thing as the other side that's above it? Y, I want to say Y. You just labeled it.
So this side right here?
Yeah.
No. You see these two sides? Don't they correspond to these two? Are these two the same? So these wouldn't be the same. They'd be proportional, but not the same. Okay. Which one do you guys want to solve? First, second, or third? Doesn't matter.
First.
Okay, I heard first. Cross, multiply. We get 8x equals 40. So what does x equal?
Sorry.
Yeah, so x equals 5. And we're talking here about feet. So 5 feet. If I work this one out, guess what I'm going to get? X equals 5 feet. If I work this out, what am I going to get? You're going to get it all with the correct proportionality.
What's 40 divided by 8?
Sorry, he had his hand.
I really, I know you're going to say you have to, but like, you don't really have to work it out. I mean, you can just look at it.
You weren't listening, were you? Okay. Let me give you one last one. How many of you got 5, though, or worked it out, could have gotten 5?
It is true, though.
Yeah, because 8 divided by 4 and 10 divided by X, K, I mean.
We want to do it
And
in that
8 divided by 4 is 2, so then you have to do 10 divided, I mean.
I'm confused.
Yeah.
So what they're saying is, could you have done just 10 divided by 2 and get 5? Of course you could. Could you do 6 divided by 2 and that's 3?
You have to find 2 first before you can work it out.
Yeah, you have to think of what's that relationship. And here, the relationship between those two is divide by 2 or multiply by 2, depending on which way you're going. Okay. Yeah, and that's the thing. I'm not going to give you decimal problems until I let you understand the whole number problems. If you could do this in your head, great. But this is better. This is harder. This is more complicated. This is more intelligence right here. So this way, I can ask a 5th and 6th grader. They'll find it out for me pretty quickly. So if you're impressed by finding it quickly, 2 years ago would have been good. But today, if I brought this to the 5th and 6th grade, they would look at me with eyes even bigger than yours. And they may not be able to figure it out because they're using a proportion, which they get some idea, but not totally.
7th and 8th grade student council, please see Mrs. Thomas during break today. Thank you.
Anyone in here, student council? Okay, so Mrs. Thomas, please. All right. On page 582, number 12. Here's where we want to do in our heads. Good luck.
Okay, I can do this.
12.
Well,
Yeah,
you can't do it in your head.
Yeah, some of these you still can do, but just make it nicer for yourself. Okay. They give us these 2 angles are the same. These 2 angles are the same. This one and this one. By the way, there are 2 triangles here. You could see the top little triangle, But do you see the bigger triangle? And if you're having trouble with this problem, divide it into its triangles. So this is what I'm going to do. This right here is triangle EAB. Congratulations. Do it with the proportion and show me skill.
Well, I did it with the proportion too. I just was checking.
Good. You can check. Yeah, good. Check. That's very valid. Okay. Here I have 4, 6, and I don't know. And this is 10, and I don't know. Okay. Who can give me a proportion here? But listen carefully, guys. Look at this carefully. This was the original shape. And I split it up into this little triangle right here and this big triangle right here. You guys see what I did? I didn't change anything. I just separated because maybe some of you can see it better. It's kind of hard to look at it sometimes. It plays a trick on your eyes. Yes, ma'am? Oh, give me a proportion.
Yeah.
Go ahead.
4 is to 6.
All right.
10 is to x.
Yes. That's a proportion. Anyone else give me something different? Max?
I got x over 6 equals 4 over 10.
X. So x over 6 is what?
Is to 4 over 10. Or I don't know.
I would get 10 is to 4. And let me show you why. X is to 6 as 10 is to 4. So we went big triangle, small triangle, and then we should go big triangle, small triangle. You see how we did that? So you could do it this way, x over 6, but then you got to do 10 over 4. Anyone do it differently? Yes? 10 is to 4. 10 is to 4 as x is to 6. That's good. There's one other way to do it. Anyone do it? Basically, you guys see x is in the top right, bottom right, top left. Can it go down there? Josie? 10 is to x. 4 is to 6. 10 is to x as 4 is to 6. That's good.
Wait, wouldn't
There are actually more.
6 is to x?
As 4 is to 10.
Say that again. 6 is to x as 4 is to 10. Yep, that works.
Wait, so basically, you can get any right answer if 6 and 10 are cross to each other?
Yes, 6 and 10 have to be crossed, and 4 and x. But they're all proportional. Yes, ma'am.
Could you do 4 is to 10?
4 is to 10. Yep. 4 is to 10 as what?
As x is to 6.
It had to be 4 is to 10 as 6 is to x. So 4 is to 10 as 6 is to x. All right, I'm going to do a little vote here. How many of you did it the first way? Raise your hand if you did this proportion. So almost half of you. How many of you did it this way? Okay, 3 of you. How many of you here? 1. How many of you here? 1. Okay. When you cross multiplied, you all get the same problem here. 60 equals 4x. Isn't that it? Then all of you get, maybe you got 4x equals 60, but you all get this problem. And so you divide both sides by 4. X equals 15. So this side right here is 15. Very nice. Feet. That's your answer. Okay? How many of you feel more comfortable with this than you did this before you started class? Yeah, okay. I'll help you out. So what you're going to do, I'm going to give you your homework, and then I'm going to have you guys, if you need a check, ask me. I'm more than happy to help. I'm going to pause you here, Swivl. Oh. Sorry, Swivl was communicating with me. I need to answer it. Okay, your homework is, 13 to 21 odd.
What?
13 to 21 odd. Yes. Page 582 to 583. About 6.
gray, you might want to look at black pen.
No, do it in pencil. You can do it in black pencil. Or gray pencil. I'm okay with gray. Yeah, so you're doing the odds on 13, 15, 17. You have your similar triangles. And then 19 and 21 are a little bit tougher. They're thinking questions. Hopefully you...
Did you get a decimal or did I do it wrong?
on which one?
The first one.
Yeah, it's possible to get a decimal. Yes. Okay. Oh, and goodbye, Swivl.